Greetings, everybody. How are we doing? We've had a lot of great content today, but we're not finished yet. We have two more exciting sessions on this track. Up next is a talk about Spring for Apache Geode from John Bloom. John, tell us about Apache Geode.
All right, thank you very much. Welcome to Spring One. Hi, everyone. Hope you and your loved ones are safe and healthy in this time. So we're going to take a look back at the past year in Spring for Apache Geode. As I said, my name is John Bloom. I'm a member of the Spring Data team, and essentially my responsibilities rest at the intersection of all things Spring for Apache Geode, not just Spring Data, but what things am I specifically talking about? Well, in the Spring portfolio, there's 4 essential projects serving as the building blocks to write Spring applications for Apache Geode. And that consists of Spring Boot, Spring Data, Spring Test. Of course, there are other projects in the Spring portfolio that also integrate or use Apache Geode, such as Spring Integration, and by extension, Spring Cloud Data Flow, but they either directly or indirectly build on these bits here, such as Spring Boot or Spring Data. So let's drill into each one of these in a bit more detail, starting with Spring Test. So like test-driven development, this will actually be a test-driven presentation. Most of my examples are test. So the past year in Spring Test for Apache Geode actually highlights 3 new features. One specifically around the fine-grained control over the Gemfire Geode mock object lifecycle. The Spring Test project itself can be used to write either unit or integration tests for Apache Geode in a Spring context. And when you're writing unit tests, you're very often probably mocking your collaborators, whether they're application components or even the technologies they integrate with, like Gemfire Geode. So Gemfire Geode creates objects like regions that your application might be using during the life cycle of your application. And so you can actually mock those objects. And now we give you more fine-grained control over that mock object lifecycle when those objects are created and destroyed. Additionally, we've provided more documentation around the caching operations, specifically the unsupported ones. So Spring Test for Apache Geode actually mocks certain Gemfire Geode objects themselves and provides default behavior. However, it doesn't do that for all cache operations, obviously, but it does do that for some of them, like region, gets, and puts. Other operations aren't supported, like queries, obviously, because it makes more sense as maybe an integration test, or is this maybe kind of unpractical to do so. And then we have this new Enable Gemfire Resource Collector annotation that I'll talk later about in an example. But first, a little bit more about the mock object lifecycle. So everything begins and ends in a unit test with the Enable Gemfire mock objects annotation. If you want to mock Gemfire Geode objects, to simply annotate your Spring configuration, specifically your test configuration with Enable Gemfire mock objects. It introduces a new attribute there, destroy on events, and that can be configured to any one of the event classes in the Spring Framework test context event package. By default, it's set to the Spring after test class event. So basically cleans up all those mock objects after an individual test class runs, which means that all your test cases within that test class will be using the same mock objects. Of course, you can configure that to one or more of the other events so that you can clean up after every test method if you like. Now it's time for an example. So I'm going to jump over to my IDE. If you have trouble seeing it, please let me know. I'm going to expand this. So I have a test class here. It's actually a Spring Boot test. And all we're going to do is we're going to create a user. So I've got this user object. It's a really simple class. There's nothing special about it. It just has an ID and a name. It's going to create a user. We're going to basically assert that there's nothing in the cache in the beginning. So we've actually got 2 assertions there, and I'll explain why in a bit. But the repository count should be 0 when we first run this. We save our user, and then we assert that the repository count changed, and then we get that user back out by invoking a repository method and assert that it's our user that we expect. By default, Spring Boot Data Geode will actually create a client cache application by default, but to basically showcase some of the the artifacts that are created by Gemfire geode process during a test cycle or an application run cycle. I've turned this into a cache server application. So it's literally a pure cache with a cache server instance that could serve clients. It's got an embedded locator. I start a manager, regions persistent, and I've configured a couple other things here. But this will actually generate some artifacts. And when I run the test, initially everything is fine, right? Like it passes and it runs successfully as we would expect. You'll see there that Spring Boot starts up and then it bootstraps Apache Geode. So this is Apache Geode outputting some stuff. And then of course, our test passes. However, if I run this again, it actually fails. And the reason why it fails is because Geode, Gemfire, whichever one you're using, actually leaves artifacts behind. So it failed on our test count there. It actually isn't 0 anymore. And if we look at our file system, I've actually configured this test to run in a specific directory. You can see there that it's got all these files that it's created. Some of them are used for the persistence of the region. Other ones are used to manage the cluster by the locator and so on. And these are just a subset of the files. There's many other files in different locations that actually get created, like if you're using cluster configuration. So that can actually be a problem for your integration test. So we introduced the enabled Gemfire resource collector annotation. When you annotate your configuration with that, it automatically removes these files for you. I'm actually going to delete them here just to reset the class itself back to its original state. So when we run it that first time, again, we would expect it to pass with this annotation added to our configuration. Again, we're going to see Spring Boot starting up, and then it's bootstrapping Apache Geode. And our machine's a little slower than normal. Hopefully it continues to run okay. Got a lot of things running here. Okay, so it runs. Now, if I run it again, it should pass because there aren't those artifacts that are left over. Of course, you could argue, whether those assertions in my test were actually valid assertions or good assertions in the first place, but really they were meant to serve a point. So there again, you can see that the test actually passed. And when we look at the file system, I refresh that, that's because there's no artifacts that remain behind. And all I had to do was actually add this annotation to clean that stuff up. Now, it's actually really easy to turn this into basically a unit-like test. It's not a pure unit test because we're actually spinning up a Gemfire, a Spring application context, but we can actually turn this into a partial unit test by mocking our collaborators like Gemfire's objects, just by doing this. If I run this, however, it doesn't quite pass yet. And the reason for that is because, well, not all the mock region operations that are called by that repository there. So we're basically indirectly calling the mock objects through the Spring abstraction. So where this test failed is, if I double click on that, we see that it failed on the count. Because what it's actually doing there is, I can't expand this, it's actually running a query. And that's one of the things that the Spring Test Framework doesn't provide to you out of the box. It doesn't provide a way to mock queries. So if I just comment this out and just look at the region size, that's going to pass. I'm not going to rerun it just yet. I actually want to say, what if we want to mock one of the other region operations? So one of the questions that came up recently was, what if we want to mock the test the region put operation, put if absent operation? So it's a lot like my test case above. We create a user. We only put that user in the region if the user does not exist already. Otherwise, it returns the existing user. So we go on to actually try to create a user with the same ID and put that wrong user in the region, and that should fail and result back into Jane Doe being the person who's actually stored in that region. However, this test won't pass either because there's no behavior for this put if absent operation. So how do we handle that? Well, Spring Test actually builds on mock-edo. So using mock-edo, and if we get an injected region reference into our test, we can provide additional behavior to the mock region itself. So I've actually already written that code, mock region put if absent. So now we've got a setup method here that's going to mock the behavior of put if absent. Yeah, get all the imports settled here. Just done. Okay, it's really slow right now. All right. So essentially what I'm doing there is for the user region that I've injected into my test class, I've mocked the behavior of the put if apps in operation. Not only can I mock unsupported cache operations, I can redefine the operations that are already provided by Spring Test out of the box, like get and put and size. So now if I run this test, both of these test cases should actually pass. And we're no longer using Gemfire live objects. We're actually just using mock objects. So we essentially have the same test case transformed into a more unit-like test. And if my machine wasn't so slow for this presentation, it would actually run much quicker. So if it was part of your build, it should improve your build times as well. And there you go. Okay, back to the presentation. It's real simple to actually use Spring Test in your Spring projects. Just go to start.spring.io, generate a Spring Boot project, and include the Spring Geode Starter test module. Spring Data. Let's take a look at what's new in Spring Data. There's actually a lot of things that changed in Spring Data over the past year. These are some of the highlights. And some of them are still a work in progress here that you can see, like paging, projections, and function executions from a repository. So let's delve into a little deeper what this means. So the Spring Data Gemfire project or GitHub repository is actually being merged into the Spring Data Geode repository as of Spring Data Lovelace or 2.3. So Spring Data Geode, Spring Data Gemfire 2.3, Spring Data Gemfire is now a module of the Spring Data Geode repository. And effectively, all it does there is it basically just replaces the Geode dependencies with the Gemfire dependencies. So if you include the Spring Data Gemfire artifact in dependency on your class path, you get Gemfire bits, assuming that you have the repository declaration configured correctly. Otherwise, by default, you're getting Apache Geode bits. And we did that largely because the code bases were the same and it didn't make sense to maintain two different code bases. It's just easier this way for consistency reasons. Event publishing, specifically transaction event publishing. So there was some work done quite a while ago. Actually, you can see here, the link below, it's been 5 years around Spring's event messaging model inside the application context when you're publishing events. Essentially, any of your managed components like an @service class here can get a reference to the Spring application event publisher and publish events, like maybe transaction events, like maybe you want to respond to a successful commit or do something when the transaction rolls back. And maybe you have very specific event types for that. And over here on the right, you can see that I have another component that registers these listeners. It's essentially through the @transactional event listener annotation that's tied to a transaction phase and then expects that particular event type and then can respond to it in some manner. Well, in Spring Data Geode, we actually did one better. We made that a lot simpler. By simply changing the configuration annotation for Gemfire cache transactions, this annotation effectively enables Spring's transaction management and then registers the Spring Data Geode Gemfire cache transaction manager as the platform transaction manager to enable local cache transactions in Geode. All you have to do is set the enable auto transaction event publishing attribute to true, and you get automatic event publishing. You no longer have to actually inject the application event publisher and manually publish events. That's because Geode's already publishing events, a transaction event in the Geode context. We're just taking that event and forwarding it on through the application event publisher for you. So all you have to concern yourself with is your event handlers now. There is a transaction application event type that's provided to you by Spring Data Geode, but it actually just wraps the Geode transaction event, and then you can extract that and inspect it and do whatever you want to do in your applications. So the features that are up and coming are projections, paging, and on-region function executions. So if you're familiar with any of the other data stores supported by Spring Data, such as Redis or Mongo, you know that there's things like projections. So in a query, you can select specific criteria. You can select star, which is all the criteria, which just returns that object. Or you can return specific information if you're only interested in the information based on the view in your application. And of course, you can order that. Sort is something that's already supported by Spring Data Geode, but projections and paging aren't. Effectively, what that would look like is this is the object that you would actually store in your region. You'd have a user class that's mapped to the user's region that would have all this additional data on it. But maybe you're only interested in the name and the last access time. And so you can create a class type Actually, I think that can even be an interface, and then we can actually proxy that as well, and have that returned from your repository method there. And then that's actually what's selected. So not only does that reduce, well, that actually reduces the amount of data that's even transmitted over the wire. So it reduces the load on your network, which is really nice. For paging, if you're familiar with some of the other repositories like Cassandra, Redis, and so on that support paging, effectively you pass in a page request, which implements the pageable interface, which allows you to specify the page number and the size of the page and a sort, and then that will return, you can return either an ordered list of users or a page object, and even use that with projections, vice versa here, and get a subset of the result set. So that's nice for also reducing that load. Keep in mind, though, that Geode doesn't actually support the proper notion of a cursor. So we actually implement it via a poor man's paging by issuing a query to get all the keys and then using those keys to select the page and then issue a query to actually fetch your data. The function execution one, I want to actually call that out individually here. It's kind of unique because Spring Data Geode already provides annotation support for executing functions on regions, on servers if it's from the client, and on members or member if you're on the server side. But repositories are already tied to a region through the user object that is associated with, the entity class that's associated with via the @region mapping annotation. So it's a natural marriage between function execution annotation support and using that from repositories. And the only thing you have to do is designate that this method is a function as opposed to like one of the CRUD operations or a query method. So now you can inject one object to do all your operations, whether they're CRUD operations, queries, or executing functions from a single interface, which is quite nice. Of course, to use Spring Data, all you have to do is go to Spring Boot or go to start.springgeode and generate a Spring Boot project. The Spring Geode starter module is already included by default, and that transitively pulls in Spring Data, so you can use all the Spring Data features. Spring Boot Data Geode also offers a lot of auto configuration for those features as well. Spring Session. So not a lot changed in Spring Session. There was a few things that were notable, like adding a profile to disable the indexes that are created by Spring Session by default. Most notable there is the principal name index as well as session attributes index, although it only creates indexes for session attributes if you call out which session attributes you want to search on in the first place. If you have done that, then it will create an index for those session attributes to search on, making your queries faster in those cases. The principal name is always a logical attribute to search on because in a security context, you're oftentimes authenticating based on principal. So we're looking up that principal by name. But you can disable those indexes now if you prefer to create the indexes yourself or just not have the indexes in general. We've changed the index type from hash to range functional indexes since the hash index in Apache Geode was deprecated due to limitations of the hash index itself. And then we also marked the identity field on the session object when using PDX serialization, which helps when you're using PDX serialization and you have different PDX serialization use cases there. So we're making sure we're continuing to do the right thing. It's really easy to use Spring Session for Apache Geode in your Spring applications. All you need to do is include the Spring Geode starter itself in your dependencies from Spring Boot Data Geode. And last but not least, growing, increasingly becoming one of my favorite projects to do things for, given all the magical things that can happen inside of Spring Boot, is Spring Boot for Apache Geode. There was a lot of things that actually changed, and I'm just going to focus on 3 things today in particular. The first is asynchronous inline caching, which I'll talk about here in just a minute. There's cache initialization. So if you're familiar with Spring Boot's feature to provide a SQL schema file, a schema SQL file, or a data SQL file for databases, relational databases, there's now a complementary feature for Apache Geode to load data into your application on startup. And then we provided support for specifying or declaring Gemfire properties inside of Spring Boot application properties. And I'll go into a little bit more detail there as well. First, patterns of caching. There's a lot of different forms of caching, actually, a lot of different patterns of caching. The one that people most commonly refer to when they're talking about caching is the look-aside caching pattern. It is, in fact, the pattern that's used by the Spring framework itself. Spring's cache abstraction in particular. But there's also other forms of caching like inline caching here. There's a sync and async variant, near caching, multi-site caching, and different configuration arrangements like active-active or active-passive. And then there's use cases of caching. So that shouldn't be confused with the patterns of caching. These are actually the application of those patterns for these particular use cases like HTTP session state caching, Hibernate's L1 and L2 caching, and so on and so forth. One we're most interested in, though, is inline caching. So I just want to talk about that in a little bit more detail. So the way inline caching works is your users of your Spring Boot applications are going to make a request. They're either going to save some data, like create data or update it on a write, or they're going to read some data. And when they do a write, that's going to result in a cache put. So when you're using inline caching, your Spring Boot applications can immediately put that into the cache. And then the cache itself, not the application, is going to be responsible for updating your external data sources. If you're integrating with a lot of different things, which is typically the case in enterprise applications like a database, a cache, a messaging system, you can configure Geo to write through or write behind to that particular database or data store. Subsequently on reads, when a user requests information from your Spring Boot application, that'll perform a cache get, and then that reads through synchronously to the database if you've configured inline caching there automatically. Your Spring Boot application doesn't need to do anything. So what does that look like from an architectural perspective for those of you that are familiar with Apache Geode? Well, under the hood, your cache or your region, which is just a key value store, a map, right, has a cache loader and a cache writer registered on it. So when a cache update occurs, that invokes a cache writer which writes through to the database synchronously. And if the cache update fails, or if the database update fails, then the cache won't be updated. So it keeps those things in sync. Conversely, when you go to read data, if there's a cache miss, then Geode will automatically invoke the cache loader to load that from the database if an entry exists. However, in asynchronous or write behind inline caching, there's no equivalent for asynchronous read yet, like in a reactive sense, but you can asynchronously write behind so that when a cache entry is updated, that gets put into a queue of events that's batched. And then eventually some other thread's going to invoke a listener that'll write back to that database. So what does that look like from your Spring application point of view? Well, it doesn't look any different. You just, your service component still has the @cacheable annotation and identifies the cache. And it's going to consult the cache whenever this method's invoked. And this method now doesn't necessarily need to access the database directly anymore. It could actually create the user or maybe throw an exception if the user doesn't exist in whatever capacity, or send the user down a different workflow, perhaps. But from a configuration perspective, it's really simple to actually enable inline caching on your region and tie it to whatever backend data store you want to. And the way we do that is through Spring Data's repository abstraction. So you basically give it a repository and the name of a region. You can also alternatively specify a predicate to use more complex matching logic if you want. But by default, you can just use the name of the region, and that will associate the repository to that region for inline caching. This is the synchronous caching, synchronous pattern. And effectively, you don't even have to worry about implementing cache loaders or cache writers, any of that stuff. The Spring Boot Data Geode project manages that for you. To do the async one, very similar there. Instead of using just the inline caching configure, use the async inline caching configure. And you additionally have the option to configure the queue itself, like the batch size or the time interval that will actually trigger that particular thread to invoke the listener that's created by default that uses your repository. So essentially any data store that's supported by Spring Data can be used, like Redis, MongoDB, Cassandra, as a backing store to your cache. And you can combine that. You could use asynchronous write behind with synchronous read through, for instance. So there's other helper classes like the repository cache loader region configure to maybe just specify one side of the equation, like when you're doing reads. There's also a repository cache writer region configure if you want to do write through as well, individually independent of say read through. But you can combine these two patterns in any fashion that you want. All right, Gemfire properties and application properties. We're almost at time, so I'm going to move along here really quickly because I got another demo I want to show you. Essentially, you can just specify all your Gemfire properties and application properties now. All you have to do is prefix it with the Gemfire prefix. There's actually Spring Data Gemfire properties that match those Gemfire properties. So if they're in conflict with each other, the last one wins. The nice thing about this is if you have a bunch of Gemfire properties already and you don't want to convert those to Spring Data Gemfire properties, you can just basically specify the Gemfire property and the Spring Boot application properties and take advantage of all the Spring features like property placeholders and defaults. So example, I'm going to do this really quickly because I know we're short on time. All right, I have an example of cache initialization, cache initialization. So essentially, this is just another test class that basically expects that there already exists some data, and it's going to add a couple of data. So I've got a Doe family here, and when I run this test, initially it fails because, well, there's no data. We didn't specify any file like a data SQL file to load initially. We are actually using live objects here. So it's starting up Gemfire. So you can see that my test class failed because I couldn't find the elements. But it's really simple. If you want to do that, you can just create a data JSON file with all the data that you want to load. You can drop that into your class path. The name of the file is a little different. It's data and the name of the region that you want to load the data for. So you would create a JSON file for each of the regions. Rebuild that so make sure that it gets copied to my class path. Okay. And if we run this again, of course, it's going to pass. And the machine's slow. Okay, last time. There's also, while this is running and we see that this test passes, also an export feature. So unlike Spring Boot Data Geode also lets you export data, which is a really cool feature. And I've actually got that in this test configured here up the top. It's not enabled by default. We don't want to enable exporting data by default, obviously, for a lot of reasons. And you can even specify where the file goes. So the original file didn't have, my other users, but when it exports that data, it's actually going to contain the users that added during when my application was running. So you see there that actually passed. All right. Some other notables in Spring Boot Apache Geode, we got a new example of multi-site caching, one on security. We got new chapter on using Apache Geode and Docker with Spring, since Spring Boot has really comprehensive support for containerized applications now. The Spring Boot Data Geode provides a lot of API extensions to Apache Geode if you're using Apache Geode's API directly, so making those APIs really easy to work with. We have a starter logging module that makes configuring logging for Geode even easier, and this new Spring Geode BOM file there that basically harmonizes all the dependencies that I talked about today in my presentation. Using Spring Boot Data Geode is really easy. Go to start.spring.io, generate a Spring Boot project. Here's all my references. When you get a copy of these slides, you can just click on these links and it takes you to where you want to go. And my call out to you guys is go check out Oliver's session here, which is starting real shortly on application events. Thank you very much. I appreciate all of you being here with me today.
All right, thanks, John. That was a great session on Spring for Apache Geode. I know John had a lot to talk about, and maybe if for everyone joining in, you wanted to talk about this more too. So you can go over and keep the conversation going by clicking on the link on the session breakout page and joining the QA session that's starting there. We're going to resume here in 2 or 3 minutes with the final session today for this track. It'll be there again about two minutes or so. So I'll see you then after the break.